right? Our objective is to use models to compare fractions with the same numerator. So we'll be looking at the same sized whole, and then we'll be comparing our fractions by taking a look at the numerator and taking a look at the denominator, okay? So a few things that you can keep in mind while we are taking a look at comparing fractions with the same numerator. So first and foremost, having the same numerator is a clue that we can work with. So the top number, our numerator, that's a clue that we can work with. And when comparing our fractions, we need to make sure that the size of the whole is the same size. So that way we can effectively compare our equal parts. And then the greater the denominator, the smaller each equal part will be. So if you look right here, this model is divided into 12 equal parts. And in this model, it's divided into 3 equal parts. I can see that the smaller my denominator, the larger my pieces are. And the larger my denominator is, the smaller my equal pieces are. So that will help you compare as well. So let's take a look at a few examples. If two fractions have the same numerator, the fraction with the greater denominator is less than the other fraction. So once again, if two fractions have the same numerator, the fraction with the greater denominator is less than the other fraction. So if we take a look at this fraction strip, I can see that we had 5/8 represented here, and then we have 5/6. So I'm comparing 5/8 to 5/6, and I can see that 5/8 is less than 5/6. I know that's true because 5/6 is closer to 1 whole. 5 is only 1 number away from 6, whereas 5 is 3 numbers away from 8. So 5/6 is greater because it's closer to 1 whole. You can also think about how, because the greater denominator means the whole is divided into more parts, so the greater the denominator, the smaller those equal parts will be. So as the denominator gets bigger, each part gets smaller. Once again, as your denominator, the equal parts, gets bigger, your parts get smaller. So 5/8, once again, is less than 5/6. So we're going to practice a few examples together. So first and foremost, I wanted to point out that we're using fraction strips to help ourselves analyze and compare these fractions. So we are comparing 3/6 to 3/3. So 3 out of 6 pieces are shaded in here. And then we have 1, 2, 3/3. So I'm thinking to myself, which fraction is closest to 1 whole? Well, 3/3 equals 1 whole. So I can see that 3/3 is greater than 3/6. All right, how about this one? We have 4/6 compared to 4/8. So I'm once again looking at which fraction is closer to 1 whole. And I can see that my 4/6 is closer to 1 whole. All right, let's take a look at this one. We have 2/3 compared to 2/4. So I can either think to myself, which fraction is closest to 1 whole, or I can compare these two fraction strips together, and I can see that my 2/3 is further along than my 2/4. I can also think to myself, 2 is closer than 3 than it is to 4. So 2/3 is greater than 2/4. All right, now we have 4/4 compared to 4/6. So I'm going to draw fraction strips to model 4/4 compared to 4/6. Remember that we want these fraction strips to be the same size to represent the whole, so that way we can effectively compare these fractions. So the first fraction strip is broken up into 4 equal parts. I'm looking at my denominator to know that. So I'm drawing 1, 2, 3 lines to represent 4 equal parts. And all 4 of these parts are shaded in. And then my next fraction, I have 6 equal parts. So I'm going to draw 5 lines. 1, 2. Ooh, that one is not too straight. We're trying to be as precise as possible. 2, 3, 4, and 5. And I'm going to shade in 4 out of the 6. So I can see that 4/4 is greater than 4/6. So I would suggest that you draw models as we're comparing your fractions. It will just help you better understand which fraction is greater than, less than, or equal to each other. So we're going to compare 2/6 to 2/3. All right, so I'm thinking to myself, which fraction is closer to 1 whole? And I can see that 2/3 is closer to 1 whole, so that is greater. Let's take a look at the next one. I have 4/6 compared to 4/6. My numerators are the same, and my denominators are the same. So these fractions are equal to each other. And the next one, we have 5/6 compared to 5/8. So I can draw 2 models, so that way I can effectively compare these fractions. So I'm going to draw a circle and split this circle into 6 equal parts, as equal as I can. I'm not a robot, so it won't be perfect. All right, and I'm going to shade in 5 out of those 6 pieces. Then I'm going to draw another circle. I want my model to be the same size, about, so that way I can effectively compare these 2 fractions. And now I'm representing 5/8. So I divided my shape into 8 equal parts. And then I'm going to shade in 5 out of those 8 pieces. And I can see that there is a bigger piece left over, right? I have 3/8 left, but over here I only have 1/6 left. So I can see that 5/6 is greater than 5/8. 5/6 is closer to 1 whole. Let me just erase these guys real quick. All right, so as you explore today's lesson and today's quick check, I'd like you to keep in mind which fraction is closest to 1 whole. So how can you think about which fraction is closest to 1 whole? I'd also like you to use models to compare your fractions. So draw up a model on a piece of paper, or you can use the models that are present with each question to help yourself better understand those fractions. And I'd like you to make sure that you double check your work, as always, please and thank you. And try your best today. Just be patient with this lesson. It does take some time to understand better. So I would remember the power of yet when you're comparing fractions with the same numerator. And if you have any questions or need any help, just let me know. But I will see a bunch of you for check-ins today. Have a great day, boys and girls. Bye.